everyone. Welcome to the video lecture series on probability. I'm Professor Mayur Gohil. In this video lecture, I shall be discussing the question that you see on your screen, that is to find the CDF of the following PDF of the random variable x. Now, as you see, because everything is given in the form of the interval, that means x is a continuous random variable. So we note down the fact over here that x is a continuous random variable. Now, in order to find the CDF, that is capital F of x, okay, so we have to find, we need to use a formula that is relating capital F with the small f. So let us see how to find this. So to find CDF of x, okay, that is our journey that we will be beginning to find this. Now the formula I'll give you is this. The formula is only one formula. It is f of x. This capital X that you see is the random variable that is concerned, and it is from minus infinity to small x f u du. This is the formula. Okay, please remember that this is the formula. This is formula, and let me now begin the quest of finding this CDF for the following PDF. Now let us do the work. Now, large number of times students have lot of confusion how to handle this. So I always suggest that you first draw a number line, okay, and on that number line you plot your intervals. So it is from minus infinity to infinity, and then it is here, if you have, suppose here it's 0, then 0 to 1, and then there is from 1 to 2, and then there is from 2 to 3. Now here you have to go portion by portion of the interval, okay, and use the same definition each time. So we say here it starts like this. Let's say when x is belonging to the interval minus infinity to 0, what is the situation in that case? Here our definition is f of x is equals to minus of infinity to x, and the value of the function is 0 over there, right? It's 0, elsewhere it is 0 given. So in this situation till here, if we say it's all 0, so the value of the function over here it's 0, so my answer is also going to be 0. No problem here, we are done. In the first case we are over. Now let's go the next part. The next part is here when x belongs to the interval. So when it is from 0 to 1, okay, what is happening in that case? Again the definition remains the same. F of x is same, minus infinity to x f of u du. Now the thing is, x is in this portion, okay, 0 to 1. So from minus infinity to 1, when it comes, the thing happens like this. The interval that is already gone, that is minus infinity to 0, that we will write minus infinity to 0. The value we don't wait, we will just write over here f of u first du, and then it is from 0 to x. We don't convert it 1 over here, though the value of x means it is from 0 to 1, it can take any value, okay, so that's what it means, and we keep it unknown in this interval, the interval in which x is standing. Okay, so we keep it like that. And then so we have f of x equals to, now we have already seen that f of u in the first interval minus infinity to 0 is 0. So we write here it is 0, and from here it is 0 to x, and the value of the function in the interval 0 to 1 is x upon 2. So I'll write u upon 2 du. Now why did I write u? Okay, uh, because I have written the function as of variable u. Okay, so when you write it is of variable u, you will need to use that variable. Okay, so let us integrate this. So when we integrate here f of x, you get u square by 4, and it is from 0 to x. So now you will get a function x square by 4, which is a function of x, and this is in the interval between 0 and 1. This is your CDF over there. That is what is meaning of integration. Integration means it's adding up all your probabilities till now. Okay, so that's what you get here. Now let us see the second part, the third part. So when x is belonging to the interval 1 comma 2, so again the same definition. Now you split your integral from minus infinity to 0 f of u du plus 0 to 1 f of u du, and now it is from 1 to x f of u du. That is what you get. Now again when you write your capital F here, so the first value is 0, so minus infinity to 0, the value of function is 0, gone. Now this small f, that is what is given here, so it is the PDF, right? So it is a PDF, so you have it as u by 2 du, and here it is from 1 to x, and now the value of the function in 1 to 2 interval that you see is half. So I'll write here it is half du. So when I integrate here f of x, I'll get this is 0. Here I'll get u square by 4 from 0 to 1. Here I'll get half, but it will be u, and it will be from 1 to x. Okay, so this will be 1 by 4 plus half into x minus 1. Okay, we can simplify this and it will become 1 by 4 plus x by 2 minus of half. Okay, so here it will be x by 2, and this is 1/4, and it will be minus of 1 by 4. Okay, so this is my CDF for the interval when x is between it is for the interval when x is between 1 and 2. This is what happens. So this is how you calculate your answer in a cumulative fashion, and this is the thing of calculation in CDF. Okay, so you have to be very careful while doing all these calculations. Okay, now what happens next? The next part is for the next interval. So when x is belonging to the interval 2 to 3, so again the same definition, but now the length of the interval will increase. So it is from minus infinity x, and it is f of u du. Small f we are gonna consider. So because the interval is like this, as we saw, it is from 0, 1, 2, 3, and other, here it is infinity and here it's minus infinity. So now we are at this position, right? So we add up all the intervals that come in between. So it is minus infinity to 0 f of u du, then it is from 0 to 1 f of u du, then it is from 1 to 2 f of u du, and then finally it is from 2 to x f of u du. Now here the value is 0. Here the value of function f of u is x by 2, right? So it will become u by 2 du. Here it is half du. Here it is going to be the value of function that we have, that is 3 minus u divided by 2 du. Okay, that is what we need to integrate and get the answer. Now let us integrate this. So for the first portion we have 0. Here it's going to be u square by 4 from 0 to 1. Here it is half, and it's basically 2 minus 1, right? And here it is going to be, now this, when you integrate, you have a chance to integrate it in a different way also, but I'll integrate in a very straightforward manner. So it is 3 by 2 u minus u square by 4. Alright, and here it is from 2 to x. Okay, so let us substitute the value one by one and get the answer. So f of x is going to give you 1 by 4, and then there is half, and here at the end we will have 3 by 2x as you plug up the upper limit. So it is 3 by 2x minus x square by 4 minus the lower limit when you plug up is 2. Lower limit is 2, so it is 3 by 2 into 2 minus 2 square by 4. That is what your answer is. Okay, so now this is 3 by 4 plus 3x by 2 minus, here it's going to be x square by 4 minus 3. Okay, and here it is plus 1. 3 by 4 minus of 2 plus 3x by 2 minus x square by 4, and it's minus of 8, so it's minus of 5 upon 4 plus 3x by 2 minus of x square by 4. That's our answer of f of x in the interval 2 to 3. Now comes the next question. When so this portion was the D portion, so E portion we will have now is when x belongs to the interval 3 to infinity. Okay, now if we integrate our function f of x, okay, from minus infinity to x f of u, when we do, we are going to get an answer which is very natural here, because it's the final probability, it has to boil down to 1. So let us see how do we get that. So use again, split up the interval over all the terms. So minus infinity to 0 f of u du, then it is from 0 to 1 f of u du, then it is from 1 to 2 f of u du, and then it is from 2 to 3 f of u du, and it is from 3 to infinity rather, but then 3 to infinity would become here, in this case it's basically 3 to x. Okay, yeah, so 3 to x f of u du. Now if you see the value of function in the interval minus infinity to 0, it's 0. Okay, it is 0 to 1 u by 2 du. Here it is 1 to 2 half du, and here it is 2 to 3 3 minus u by 2 du, and here the value of function, even if you try to integrate, it's going to give you 0. The thing is, it is in the interval 3 to infinity, and we have already written in our main question itself that 0 elsewhere. Beyond 3, the value of function is 0. Okay, here also the value of PDF that we have is 0. In this interval it is 0. So what when we go what happens when we go for calculating the CDF over all the intervals and add them up? What happens is that our answer changes to 1. If you calculate all these integrations, it's going to give you 1. So let us do verify it manually. So what happens here is u over 2 is u square by 4 from 0 to 1, and here it is half from uh, 2 minus 1 you will get here. Here you will have 3 minus u over 2 the whole square into over minus 1, right? And it is from 2 to 3, that's the integration. And then when you integrate here, it's 1 over 4 1 by 2, and the upper integral, here you can keep a minus sign outside and then solve this integral. So it is 3 minus 3 the whole square by 4 minus it's going to be 3 minus 2 the whole square by 4 gives you 1 as your final answer. Now this was very evident here because you are taking all the intervals and adding them up, so it is nothing but the integration of PDF from minus infinity to infinity basically. But now when we go to write our CDF, okay, so over the entire interval, so we need to write like this. So we write here, therefore the required CDF of x is, we will need to write it down carefully because this is very important, that is capital F of x. So this is how you find a CDF, and it's a slightly lengthy. What you need to just remember, each time you place your variable in an interval and you check what all intervals have happened previous to that, and that way you go on adding up your probability answer, and in the interval in which you place your arrow, you get that interval, you keep it upper limit, you keep x, and then you get your answer. So this is the trick to solve how to find the CDF of any distribution. So I hope you liked it, and you will benefit from the calculation. um, if you have understood it, please hit like, share it with your friends, and let me know your feedback in the comment section. I would be happy to help you. Till then, keep solving good amount of mathematics. I shall soon see you in the next video lecture. Thank you.